Before we get started with this lesson, I wanted to talk about something that's very important to realize. When we're talking about multiplying fractions, and it's going to really play a big role in this lesson that I'll talk about later, but for right now, if I'm just multiplying these fractions together, so for the first one, 1/3 times 1/2. Again, if you're multiplying fractions, you need to multiply straight across. So it'll be 1 times 1, that's 1, and 3 times 2, which is 6. The thing that I want you to realize before we get into this lesson is whenever you take two fractions that are less than 1 and you multiply them together, their product, in this case 1/6, is less than both of the original fractions. It's less than 1/2 and it's less than 1/3. And that works every single time you multiply two fractions together that are less than 1. And I can't prove this to you right now, but you're going to have to take my word for it a little bit. We'll go down to the next one, and I'll show you again. 1/10 is a pretty small fraction. 1/200th is even a smaller fraction. But when I multiply these together, 1 times 1 is 1. 10 times 200 is 2,000. And again, our resulting product is less than the two original fractions. It's less than both of those. So I'm going to get into, like I said, what that means in just a bit. But this is going to go a long way with what we are going to learn in this lesson. So in this lesson, we are going to be discussing the probability of independent events. A math class has 1 girl and 4 boys in the 7th grade and 4 girls and 4 boys in the 8th grade. So this one class has 13 students in it. Some of them are 7th graders, some of them are 8th graders. The teacher randomly selects a 7th grader and an 8th grader from the class for a competition. What is the probability that the students she selects are both girls? Okay, so first of all, I'm going to again write down what I've been writing on every single one of these is that we're using the same thing every time. Win over possible. And in this case, the teacher is drawing things twice. So we're going to have basically two different probabilities here. For the first one, when we're talking about the 7th graders, we have 1 girl and 4 boys in the 7th grade. We want to pull out a name of a girl. So for this one, for the 7th graders, it's going to be, again, win over possible. A win would be considered a girl, so that's just 1. And possible, how many students are 7th graders that are possible to have their names pulled? There are 5 7th graders in that pot. Next, we have another one as well. So that one goes with the 1/5. We have another one. I'm going to change colors for it here. We have 4 girls and 4 boys in the 8th grade. The teacher wants to randomly select an 8th grader that's a girl. So to win here, we need another girl. Well, how many girls are in the 8th grade? We have 4 girls. How many students are in the 8th grade? We have 8 students. 4 girls and 4 boys. So this one goes with the 8th graders. And now we have to think, what should we do with these two fractions? We have two fractions, but we can't have two answers. We need one answer that shows the probability that she selects both girls. Well, we really have 4 options here. We can add, subtract, multiply, and divide. The answer for independent events is to multiply. And we're going to figure out what our answer is first before I explain why we multiply. So if we multiply these things, we will get 4 over 40, which is the same thing as 1/10. We are going to write it as a fraction in simplest form, so I don't need to change that to a decimal or anything. We're just going to leave that. That is our answer. Now, how could I possibly check to figure out if that even makes sense? Well, if I'm doing it twice, if I'm pulling out two tests, I need both of them to be true. I need this one to be true and this one to be true. First of all, the first one that we have on the left here that's highlighted, the 1/5, that's already a pretty slim chance of happening. If I just gave you 5 names in a hat and only one of them was a girl's name, it's not going to be very often that you pull out the girl's name. In fact, it'll be exactly 1/5 of the time. So that's already a pretty low probability. And then on top of that, you have to do it again. And in this case, you've got 4 girls and 4 boys. That's going to happen about 1/2 of the time, or 4/8 of the time. So both of these fractions are pretty not unlikely to happen. But we wanted to figure out a probability of both happening. Where does it say that? Yeah, both. We have that right here. We want them both to happen. So this is why I brought up the fractions and multiplying them at the beginning of the video. 1/10 is actually pretty perfect. That's a very slim chance of happening, and it should be, because both of our fractions on both of these are pretty poor chances of happening in the first place. And if you need both of them to happen, it's going to be an even smaller chance to get both of them to happen. Okay? Let's move on to the next one. A spinner has 5 equally sized sections. So I'm not going to obviously be able to draw it perfect, but it'll look something like that. 5 equally sized sections, one of which is gray. There's my gray one. And the other ones are blue. 1 gray and 4 blue. The spinner is spun twice. What is the probability that the first spin lands on blue and the second spin lands on gray? Again, we have 2 separate spins here. We're going to have 2 separate sections, and then somehow we're going to have to combine them at the end. Can we go back up to the title of this really quickly here? It says independent events, and we said independent events we multiply, but we got to think about this one here for a second. Are these independent events? Does one spin affect another spin? Obviously not. If you're spinning, you don't have to take out a piece of the spinner and spin again the next time. A spinner is going to have the same amount of pieces every time. It doesn't change based on, just because you've spun a blue doesn't mean that you're going to spin a gray the next time. So these are independent events. We are going to have to multiply, and our multiplied number should be less than both of our original fractions. So if we want win over possible, I got to change back to a pencil here. Win over possible. For the first spin, we said we wanted the first spin to land on blue. What are the odds of that happening? Well, we have 4 blues that would be considered a win. 4 blues that would be considered a win. And we have 5 total possible areas to spin on. On the second one, okay, so I'm going to actually highlight that one. That's our first spin. On our second spin, we want it to land on gray. So for our second spin, there's only one possibility of winning if we wanted it to land on gray, and there are 5 possible that it could land on. I'm going to highlight that one too. These are independent events, and independent events need to be multiplied. And as we finish this up, we'll just multiply straight across again. So 4 times 1 is 4, 5 times 5 is 25. And our answer should be less than the 2 original fractions we came up with. And it is. 4/5 is a pretty high chance of happening, and 1/5 is a pretty low chance of happening, but 4/25 is even lower than 1/5, because 5/25 would be 1/5. So we have an even lower chance of getting them both correct. Okay. That is it for this one. I hope it made sense.